Right. So let's. So we are going to find the phase difference of two particles. Two particles at a distance, at some distance. Right. Suppose it is x. So what it does mean? Here's our wave. Right. With our wave vector. Suppose the wavelength of this wave is lambda. Wavelength is lambda. So which is the distance between these 2 points. So this is lambda. Wavelength is lambda. So now we are going to find out. Suppose there's a point at here, a particle at here, at a distance simple x, away from the origin or initial position of the wave. Right? It can be any position, right? But here I took x. I measured x from this point to here, right? So these are the two particles, 1 and 2. Right? Now we are going to find out the phase difference between the particles with distance simple x. This is the expression. Phase difference means phase angle, right? Difference of phase angles of these two particles. How we get it? Right. So tell me, phase angle or phase difference of particles with distance lambda apart. Right. So what is the phase angle of two particles that the distance is lambda? Go back to the definition. So what is the definition of lambda? Wavelength. We define wavelength is the shortest distance between the two particles with same phase, which means phase difference is 2.25. Sorry, 5/2. So this is complete one cycle. 2.5. Right. So phase difference of two particles is distance lambda apart is 2.5. 2.5. Right? Lambda distance is equal, phase difference is 2.5. So then phase difference of particles with distance simple x apart. So that is the phase difference, we name it as phi. So we get 2, 5 for lambda distance, it is 2, 5 phase difference. Right? So this is a distance per phase difference per unit length. You can go. For it is for lambda distance, phase difference is 2, 5. Then what if for existence? Right? Lambda distance again, phase difference is 2, 5. Then what is the phase difference for distance x? Right? Lambda 2, 5 now it's the that's it. Right? As simple as it, right? So then phase difference of these two particles with the separation of x is given by 2, 5 over lambda times x. This is the expression. Right? Suppose we have a wave of speed 300 meters per second and its frequency is 100 hertz. 100 hertz. Right? So they ask us to find the phase difference of two particles with separation of 1.5 meters. So how we get it? Right? Question asks, there's a wave of speed 300 meters per second. Before that, a simple then we have a wavelength of a wave is 2 meters. So question asks, what is phase difference of two particles with separation of 1 meters? How we get it? Phase difference of two particles with distance 1 meters apart. Right? So 2, 5 over lambda times x is the expression. So phase difference is lambda is here 2. Right? For 2 meters, phase difference is 2, 5. So then for 1 meters, what is the difference? 5. 5 is the right? So phase difference of two particles with separation of 1 meters in this wave is equal to 5. In the previous example, velocity is 300, frequency is 100. Frequency is 100. So phase difference of 0.75 meters distance apart. Two particles with separation 0.75 meters apart. So how do you find it? Right? So first we need to find out lambda. So how do you find the lambda for this wave? V equals F lambda. Use V equals F lambda. V equals F lambda. V is 300. F is 100. Lambda. Lambda is 3 meters. Then the phase difference is 2, 5 over lambda times x. 2, 5 lambda is 3. X is 0.75. So there are 4 0.75 to 3. So answer is 5 over 2 radians. 5 over. Right? That's how we get it. Right? Topic is the phase difference. Yeah, no? The phase difference of two particles. The phase difference of two particles. Phase difference of two particles. Two particles which are at distance equal to wavelength. Distance equal to wavelength. Apart is 2, 5 radians. Is 2, 5 radians. Suppose Now we need to, now we need to find out the phase difference. Find out the phase difference of two particles. Phase difference of two particles which are at simple x distance apart. Right. So now you can draw this and write down. Y is the phase angle. X is the distance between the two particles. Right, write down all the things. Write down after here. Example one is when the lambda is one, x is 2 meters. Yes. This example. Following Sunday morning, we have the online institute discussion. So simple harmonic motion will be discussed. All the past questions in simple harmonic motion. I think selected questions के बाद ना Right. Next example. Speed of a wave. Speed of a wave is. Speed of a wave is. Speed of a wave is 200 meters per second. And its frequency is 100 hertz. 100 hertz. Find the phase difference. Find the phase difference of two particles which are at 25 centimeters apart. 25 centimeters apart. This is right. You're right. I got the extra and right. So what is the answer? 504. 504. Right. Answer. 0. Question was about the phase difference. So how can we 0.25? Phase difference of the angle in radians. So you divided 5 over. Keep it like 5 over 4 5 over like that. Alright. Come on. So what is the wavelength of the wave? P equals f lambda. So frequency is 200. Sorry, wave speed is 200. Frequency is 100. Lambda. So lambda is 2 meters. Lambda is 2 meters. Then the phase difference is 2 pi divided by lambda times x. Right? So question asks is 5. 2 pi. Lambda is 2 meters. X is 0.2, 25 centimeters mean 0.25 meters. 0.25 meters. 0.25 means 1 over 4. 0.25 is 1 over 4. So angle is pi divided by 4. in radians. So phi is 3.14. This is the angle on phi over. Right. So now you know how to find the phase difference between 2 points of a wave. Wave the phase difference and right. Okay, right, member 3. Right, concentrate. Right? Okay, so now mark these points. Right, so now we are going to discuss about points in phase and point out of phase. Points in phase and points out of phase. In a wave. So what are the in phase points and out of phase points in a wave? Right? Yeah, in phase means they have same kind of motion. The points which have same motion, same kind of motion are in phase, right? So we can easily identify in phase positions or in phase points. The phase difference of two in phase points are it's a multiple, even multiple of 2 pi. Oh, even multiple, sorry, not even multiple of 5. If the phase difference between 2 points is 2 pi, or if the phase difference of 2 points is 4 pi, 6 pi, those points are in phase points. Right? Those points have same kind of motion. Anchu දෙකක් අතර කලා වෙනස phase difference එක 2 pi වෙනවා. එතකොට 2 pi ගේ multiple එකක් වෙනවා නම් කියනවා. Right? So those points are in phase points. Right? So what are the in phase points? You can see here. Does A and C in phase? A and E in phase. Both these A particles and A and E have same motion. A and E in phase. And A and is G is in phase? No. A and I is in phase. There are them. Right. So here the in phase points you can recognize in phase points. A and E. A and E. So A and I in phase. That's all. No. Is B and F. B and F, these 2 points, the phase difference is 2 pi. Right? We have one point, the particle at B, the motion, direction of motion is downward. This also tends to go down. So both these particles have same kind of motion. So they have like motion. So B and F, they are they have same kind of motion, they are in phase. What else? D and H, yes, good. D and H in phase. D and H. But C and what? C and G. E and G in phase. C and there are number of men, but then E and I in phase. E and I in phase. Difference is 2 pi. Right? The number. So what are the points out of phase? Points at out of phase. Out of phase. Right? They have phase difference pi or multiple of odd multiple of pi. If the phase difference is pi or it's odd multiple, like 3, 5, 5, 5, 7, 5, like that. B and E not. Oh, B and E not. A and C, yes. Phase difference is 5. A and C is out of phase. So B and D. B and D out of phase. B tends to move down, D goes up. Opposite motion. So B and D out of phase. Right? So out of phase points A and C and B and D. B and D. So what else? D and F, yes, out of phase. Those are out of phase. The phase difference is 5 or it's integer multiple. It's not integer. It's odd multiple. That B and H, these two phase difference is, I think this phase difference is something like 3, 5 or something. B and H, B goes down, H goes up. So B and H. So these are in phase points, right? B and. So what kind of motion B and E does? Is that they have opposite motions? No. B bar. What is the direction of this one? Goes up, but the position and the velocities, the difference. The make opposite angle 5 වෙනවා මෙයා මේ පැත්තේ peak එකට යනවා මෙයා මේ පැත්තේ peak එකට එනවා අනිත් opposite අර pendulum එක ගත්තොත් right phase difference 5 means if the one pendulum is at this position the other one must be at the opposite end, right? So E means point at E is a point something like here, pendulum at this position. Right, phase difference is not 5. It is actually 3 pi over 2. Right, because 3 pi over 2 phase difference is not 5. मेरे नंतर मैं आयो मैं मे පැත්තෙන් කියලා වෙන්නේ मैं අනිත් පැත්තට යන්න කියලා amplitude එකේ in C and D in phase. So sorry, out of phase, but the motion of the C is C particle C goes down, E goes up. Right? They have same displacement. Displacement must be same. Displacement is same. मैं यहाँ पे B के में displacement लेते हैं, मैं यहाँ पे zero displacement. Displacement also should be same. Right? Alright, so these are the phase and out of phase and in phase point. Topic again. In phase and out of phase points in a way. In phase and out of phase points. Out of phase points. Well, yeah, some topic is in phase points. In phase points. In phase points. Then 2 points on a wave, 2 points on a wave, 2 points on a wave are in phase. 2 points on a wave are in phase if they are at the same stage of vibration, same stage of vibration at the same instant, at the same instant. Point again. In phase points, in phase points have same displacement, from the equilibrium position, and they move in the same direction, phase difference is given by expression 2 pi n. Right. So n is 0, 1, 2, 3 like this. N is 2 pi n. Sorry, pi is 2 pi. N is equal to 0, 1, 2, 3 like this. So n 0 will have phase difference 0. N is 1 means phase difference is 2 pi. N is 2, phase difference is 4 pi. Right, there's out of phase points. Out of phase points. Two points on a wave are out of phase if they are at opposite stages of vibration at the same instant. Expected. Out of phase points have equal displacements, but on opposite side of the equilibrium position. They move in opposite directions. Phase difference is or 2n plus 1 If n is 0, phase difference is 5. N is 1, phase difference is 3, 5. Right? In decrease, it should be 180, 540, 900 in angle. So 5, 3, 5, 5, 5. Like this. Phase angle. Right, so now you can draw this. These are the examples. There are more points you can find here, right? Right. Make a theory, not like mechanics. But you can Okay. Right. So we have to wait for some time, right? It will take 2 or 3 weeks to get that older way mechanics working. Mathematics use maybe next week. The sound waves gonna start actually make questions exam level questions essay type questions pass right. So no? Right. එතකම මේ ඔක්කොම බේසික්ස් අපිට තියෙනවා මේ ෆන්ඩමෙන්ටල් තින්ග්ස් තියෙනවා ඒවා අපි කලෙක්ට් කර කර යන්න වෙනවා. So wave fronts, right? So always fronts mean front defense. In the other defense, front circle. Okay, so what is a wave front? Wave front. What are the wave fronts here? Yes, what happens when you disturb the water surface? Yeah, they move like a circles and rings. Okay, so those are wave fronts, right? So actually, what is the definition of a wave front? It is an imaginary line which joins the particles which are in same phase. When a wave propagates in a medium, we can identify number of particles which are oscillates in same phase. Right? Ekam phase එකේ තියෙන particles, there are a lot of particles. So if you join them, right? This is imaginary. We can't join them actually. Many particles together. So if you join them and draw imaginary line, so that line is a wave front, right? So there are different types of wave fronts, right? So we have already mentioned one type of wave fronts. Yeah. What is the shape of that wave front? Circular wave fronts are one of them. So what else you can see wave fronts? The wave fronts emitted by those bulb, a CFL bulb. So like a cylindrical shape, or if it is a tube, this one, the wave fronts emitted by this light source. Light source emitting on the ground. Make it another wave front. If it is a point light source, what is the shape of the wave fronts it emits? Spherical wave fronts are there. Spherical, right? So if you disturb the water surface using what we say thin sheet of something like this, make a disturb them. So what is the shape of wave fronts it produces? Maybe they make a oscillate them. They are playing with not the plane. Yeah, linear wave fronts. Linear wave fronts. Right? So a light source like a tube. There's a tube light source there. So wave fronts emitted by this tube light source is a concentric cylindrical type wave fronts. So it can be cylindrical. Wave fronts can get cylindrical type, spherical, circular, linear, planar, and much more. Right? So what depends on the type of the wave fronts depends on what? The nature of the shape of the wave fronts depends on what? Not the wavelength. Not frequency. Shape of the wavefront. If this light source is a point source or like a spherical shaped one, the wavefronts of those light sources is spherical. If it is a tube shaped like tube, the wavefronts are cylindrical. Okay? So what is the difference? Shape of the source. Shape of the source. It depends on the shape of it. And the medium. If the medium is a 3D space, the wavefronts are three-dimensional. If the medium is like a surface of water, it's two-dimensional. So it is a 2D one. Linear, like that. Circular, they are two-dimensional ones. Understood? Okay. So then the key another factor is the wavefronts. Another key factor about wavefronts, they propagate direction of traveling or direction of moving of wavefront is perpendicular to the wavefront. That is something again. The direction of the wave moves. The direction of the wave is always normal to the wavefronts. Right? Suppose we have suppose just circular wavefronts. These are circular wavefronts. Circular wavefronts. Right? So if you draw normal to these wavefronts, these are the normals to these wavefronts. So this shows the direction of wave travels. This is the direction of wave travels, right? So wavefronts are normal to the direction of wave travels, right? So if we can take this direction, the wavefronts must be normal to the direction of wave travels. Wavefront right? So wavefronts moves normal to the direction of wavefront. And so there are infinite, you can draw infinite number of wavefronts. Right? You can draw infinite number of wavefronts. So how do you pick certain wavefronts to demonstrate? So what is the condition? What is the condition we consider? Right? So you can draw any number of wavefronts in between these two. But we draw only selected wavefronts. Some chosen ones we draw. Not all the wavefronts we are going to draw. Some certain, selected wavefronts only. We draw selected wavefronts only. So what is the selection? How we select those wavefronts? What is the condition? Remember, this is the condition. The distance between two successive wavefronts must be equal to the wavelength of the wave. Distance between two wavefronts, two adjacent wavefronts must be equal to lambda. So distance between each of these wavefronts is lambda. Right? And so by saying that, so what would be the phase difference of particles in two wavefronts, two adjacent wavefronts? What is the phase difference of two particles in two consecutive wavefronts? Phase difference, the separation is lambda. So what is the phase difference of two consecutive wavefronts? Phase difference of particles is 2 pi. Phase difference is 2 pi. Right? So you need to pick particles, right? If you want to draw the wavefronts, you need to draw them as the particles, the phase difference of the particles of two adjacent wavefronts must be 2 pi. And also separation between two adjacent wavefronts should be lambda. But Oregon told me, Haranga lambda samana difference in wavefronts and Adin. You give in the particles, the phase angle difference, phase difference, 2 pi value. If the phase angle of this wavefront is theta, so what is the phase angle of particles in this wavefront? Huh? What should be the phase angle of particles on this wavefront? If the phase angle of particles in this wavefront is theta, phase difference must be 2 pi. Then the phase angle must be 2 pi more than theta. 2 pi greater than 2 pi more than theta. So it is 2 pi plus theta. So what is the phase angle of this wavefront? Phase angle of particles on this wavefront? It should be 2 pi more than this one. So it is 4 pi plus theta. Like that. May I phase angle like that? It will not 2 pi. We are ready to do. The difference is 2 pi. The difference is 2 pi. The meada kali ne meya mula thiyenne. Thenawada? Then me wavefront එක මෙතන wavefront එක generate මෙයා generate කලින් තමයි මෙයා generate වෙන්නේ. The particles are already in motion. තේරෙනවද? The මේ wavefront එකේ එක්කෙනා එකපාරක් උඩ යන්න කලින් මම එකපාරක් ගිහින් ලයිට් උඩට යන්නේ. 2 pi is angle radian. 2 pi is a radian angle. 2 pi is 360 degrees. 2 pi radian equals 360 degrees. No. Me angle එක මෙයාගේ motion එක. මේ so මේක පැත්තෙන් බලුවා. Side view of this, right? Side view of this wavefront when the normal surface එක මෙහෙම තියෙන්නේ. මෙහෙම තියෙන්නේ මේ පැත්ත මේ එකක් අක්කා. මෙතනින් පටන් ගන්න. Right? මම මේ කතා කරන්නේ මේ particle. දැන් මෙයා කියන්නේ එක wavefront එකක්. ඒ කියන්නේ මෙතන ඉන්න එක නා මේක. phase angle එක theta. මේ අනිත් එක. මෙයාගේ angle is 2 pi theta. 2 pi plus theta. They have same motion. මෙයා තියෙන crest එක මෙයා තියෙන crest එක. හරි? මෙයා එකපාරක් ඇවිල්ලා ගිහිල්ලා තියෙන්නේ. full cycle එකක් කරලා ආයෙත් ඇවිල්ලා තියෙන්නේ. තේරෙනවද? මෙයා මෙතන ඉන්නකොට මෙයා ඊට වඩා සම්පූර්ණ එක cycle එකක් වැඩිපුර කරලා මෙතෙන් ඇවිල්ලා තියෙන්නේ. So that's why phase angle 2 pi plus theta. එක cycle එකක් වුණා නම් angle is 2 pi. මොකක්ද තේරුණාද? හරි? මේ ටික මේ wave එකේ මෙහෙම යනකොට දැන් මේකේ ඔය වගේ තියනවා නෙමෙයි. මේ වගේ ඔය crest එකේ තියෙන crest වල තියෙන particles තියෙනවා වටේටම තියෙනවානේ. ඒක join කරාම මොකද මේකේ? top view එක ගත්තොත් එහෙම තේරෙනවද? මේ වගේ තමයි මේක දිගටම මේක තියෙනවානේ. කොහොම දිගටම තියෙනවා මේ වටේටම මෙහෙම යන points ඔහොම යන්නේවා. මේක දිගටම තියෙනවානේ. so ඒක join කරාම තමයි circle එකේ. ඊට පස්සේ එකක් wave එකට පස්සේ තව එකක් කොම් crest එකක් යනවානේ. ඒක join කරාම තමයි ඊළඟ wave front එකේ. තේරෙනවද? එතකොට man give the phase angle and difference is 2 pi. Those are the main things. Make a difference එක 2 pi වෙන gap එක කියන්නේ length එක ගත්තොත් එහෙම consecutive wavefronts දෙකක් අතර length එක wave length එකට equal වෙනවා. Right? හරි. ලියන්නකො මේක. By the topic wavefronts. Wavefronts. Wavefront. But yeah, a wavefront is an imaginary surface an imaginary surface, joining all points that are vibrating in the same phase, Right. Then write the characteristics of wavefronts. All points on a wavefront, have the same phase. Second one. Direction of propagation of the wave is perpendicular to the wavefront. That one. Distance between two adjacent wavefronts is one wavelength, which is lambda, right? Next is phase difference of the particles vibrating on the two consecutive or two adjacent, consecutive wavefronts is equal to two pi, which is 360 degrees. Pi being an angle 360. Okay, so then types so this is if the angle is theta, the phase angle of these particles on this wavefront must be 2 pi plus theta. This is 4 pi plus theta, like this. Right. Hurry up. Right. From next week onwards, else we can start a new lesson parallel with this one. So there are three options. So we can start optics. Or either we can start force fields, right? Fields, the fields, gravitational, electrostatics, like. Or either we can start the properties of matter lesson from viscosity and surface tension. It's a small lesson. Optics. Take that one. So we'll start optics. This is optics. This is class extra training in classroom. Hey, come this is for the this is one classes or types of wave fronts. Types of wave fronts. Types of wave fronts. Right. First one is spherical wave fronts. Spherical wave fronts. Spherical wave fronts. Spherical. Spherical wave fronts. They generally produced by the point light source. Right? There's a point light source is there. Because spherical in the vacuum 3D. 3D space එකේ මේක propagate වෙනවා. Right under it, spherical wave fronts on the other. Produced by a point source of light. Produced by a point source of light or sound. Point source of light or sound. Wave fronts are concentric wave fronts are concentric spheres. Concentric spheres centered on the source. Centered on the source. Like so model like spherical spheres in the vacuum in the field we go there here. I want to be mad. Draw this. Like right? What Google 3D and 3D if you are a Picasso like I'm not right. Right. The second one is cylindrical wave fronts. Cylindrical wave fronts. Cylindrical wave fronts. Produced by cylindrical wave front produced by a line source. A line source. Wave fronts are concentric cylinders around the source. Right? Suppose this is the source, and the wavefronts are concentric cylinders around the source. Right, Aditya. Right. Next one is plane wave fronts. plane wavefronts. Plane. So these wavefronts, these spherical wavefronts are get planar when it travels far distance. What are the right? Suppose that these spherical wavefronts, they travels far. So then these wavefronts become plane, with plane venom. Right? So these wavefronts produced when spherical wavefronts travels far, it get plane. As a temporal plane, these wavefronts produce when the source is very far. These wavefronts produce when the source is very far. The source is very far away. Source is very far away. Spherical wavefronts. Spherical wavefronts has traveled large distance. Right. The next one is circular wavefronts. Circular wavefronts. Right on rate. Water waves produce at the surface of the water. Due to the vibration of a spherical object. Or spherical source creates circular wavefronts. Produce circular wavefronts. Right. So that's the thing about wavefronts. Now that's over. So again, what is a wavefront? So you need to define. You may have to define the question paper. They may ask what is a wavefront. What should you answer? Wavefront is an imaginary line of surface. The line is imaginary. You can see the wavefront, but the imaginary line you draw, can you see that circular line? Imaginary joint color rest එක අපේ line එකක් පේන්නේ now but they have a thickness, it's not line එකක් වගේ මේක පේනවද circular. You can see the shape, but you cannot see the line there. Hari, there were lines there. Shape. Point එක particle එකකට තියෙන්නේ. ඔය කතා කරන particle and water line එක මේ decline එකේ there are a lot of particles here. Line joint particles. Same phase in particle joint of line එක. M line එක පේන්නේ නැහැ, M line එක නැහැ. Particles වල ඔයාලට පේනවා line එකක් මෙන්න මෙහෙම line එක ඔය එකේ line එක මෙන්න මෙහෙම එකකට top view එකේ පේන්නේ ඩිප් කරුවොත් එහෙම ඒ කියන්නේ මෙන්න මෙහෙම හරි දැන් මෙහෙම තියෙන line එක මේ line එක පේනවා මේ joint කරන line එක මේක තමයි water surface එක හරි surface එක උදේ වේව කොහොමද කොහේද මේ peak එක peak එකේ තියෙන peak එකේ lines වලට line එකක් පේන්නේ නැහැ වෙනම line එකක් පේනවා මේ imaginary line එක අපි යනවා ඒක තමයි අතට මේක particles එකක් තමයි එතන තියෙන්නේ
දැන් මම කියන්නේ circular
ඔව්
spherical waveforms වල දැන් කිව්වේ තේනවා නේද circle
ඒ යාගේ image එක පේනවා හරි
ඒකට දැන් මම ඒකට line එකක් මෙන්න ඇඳ යනවා තේනවා circle ඒක particle එකේ connection එකක් වෙන්න බෑ ඒක particle
ඔව්
ඒ කියන්නේ ඒතර particles ගොඩක් තියෙනවා කියන්නේ
ගොඩක් තියෙනවා but the amplitude of all the particles are not same Possible differences තියෙන එක particle එකද peak එකද කියලා කියනවා bunch එකක් peak එකේ නැහැ peak එකට හිටුව තියලා ඉන්නවා එක particle එක මේ වගේ topmost particle මෙතනදී අයගොල්ලෝ join කරොත් මෙහෙම තියෙන particles ටික කොහොමද මේ particle එහෙම line එකක් උඩට පේන්නේ that's it the image line එක කියලා කියන්නේ image එක පේනවා තමයි ඒක ප්‍රශ්නයක් නෙවෙයි පේනවා definition කියලා imaginary line although it is imaginary I can see කියලා I can visualize මොන පේනවා ඒක ප්‍රශ්නයක් නේ right එතකොට මේ එතනින් wave forms වල කතන්දර ඉවරයි so now we have became we have come to a point actually another part is starting so hereafter we need to discuss about properties of waves properties of waves topic කියනවා පොඩේ අර පටන් ගන්න properties of waves is the next topic. The brain boost එකක් තියෙනවා MCQ එකක් ඒක මම කියන්නේ ඒවලදී the next stage you are starting the properties of waves right so before that I give you the brief introduction of what we are going to talk about so what are the properties of waves mean all the things have some properties. You also have some properties or features. Properties තමයි. You want your vehicle or properties නැහැ. අదే or you want your house and මොනවා හරි විදිහට. නැහැ. Nothing you එහෙමද? නැහැ. Properties means the features or characteristics it shows. your properties කියනවා නේද? අර අපි every person has a different characteristics, different attributes. So you can identify them by looking at their features and things. Right? So what are the properties that humankind has? What are the properties the things they show us? Right? Things they what are संतोषी के करते हो कुमारी का वेलकम हम चाहिए ना बड़ा बेची कौन है क्या टाइप्स अरे कौन है वेव्स वाला तीनों प्रॉपर्टीज कौन आते हैं बायोलॉजी वेव्स का करने हैं सेंटर Right. So what are the properties of waves? The things where the phenomena wave exhibits. They are the properties, the phenomena that waves can undergo the reflection. Yeah, reflection. Refraction is a wave property. Deflection or diffraction. Diffraction is a wave property. Superposition is a effect of interference is a wave property. Polarization, yes. Reflection, refraction, diffraction, interference, and polarization. Those are the wave properties. Out of those properties, interference, diffraction only exhibits by waves. Wave only exhibits. The particles can undergo, it can reflect, what it can be polarized, but diffraction and interference, right? Only wave can show diffraction and interference. So we are going to learn what are these phenomena, what is interference, right? How the two waves get interfered and what happens thereafter. And the reflection, especially next day when we start optics, the reflection is again refraction. Actually, refraction is again revised. Right? It is a properties of waves. Can I come and not take a topic here? I'm not taking it here. Right? Then properties of waves. Properties of waves. Again, reflection, reflection, refraction, diffraction, diffraction, interference, and polarization. Polarization phenomena are considered as properties of waves. Out of these phenomena, diffraction and interference. Diffraction and interference are only exhibits by waves. That they exhibit by waves only. Not only exhibit by waves, out of these phenomena, interference and diffraction exhibit by waves only. තරංග විතරයි එක එක්ස්පිට කරන්නේ. නැත්නම් අපෝට ඒ විදිහට ඒකට වේව්ස් විතරක් එක්ස්පිට කරනවා. ඒ දෙක විතරක් එක්ස්පිට කරනවා කියන අයිඩියා එක තමයි ගියේ. Right. So we'll finish our today's work on waves theoretical part එක අපි ඉවර කරමු. But so let's quickly shift on to the brain booster 23 paper is due. So only one question we have discussed last week. Brain booster 23